Hello and welcome to Trevor's Tutorials. I'm Trevor Slocum. In this tutorial, we'll learn how to create and load tile maps using the EbiTengen game engine. We'll learn what tile sets and tile maps are, what the tiled map editor is, how we can parse tile set and tile map files using the GoTiled package, how to load tile images using the subimage operation, and how we can render a tile map onto the screen. Tile sets are sets of image tiles used in tile-based video games, and one or more tile set may be used in a map or game level. Each tile set is assigned a unique ID number, and each tile in a tile set is also assigned an ID number. Here we have a tile set which is 64 pixels wide and 64 pixels high, and each tile in the tile set is 8 pixels wide by 8 pixels high. On the left we see the tile set with a grid overlaid to help us visualize the boundaries between each tile. And on the right we have the actual tile set as it appears in our game. Tile maps are grids containing one or more layers of tiles, and each tile is referenced by the tile set and tile ID number. The tiles may also have some other attributes, such as being vertically or horizontally flipped. Because tile maps are mostly ID references, they're very efficient for constructing large game worlds. Some tile maps also support defining custom objects with custom attributes, and it may even be possible to give these custom objects an exact pixel position, rather than needing to position them within the tile grid. Tiled is a free and open source map editor for tile-based video games, and you can find it at mapeditor.org. We'll use Tiled in this tutorial to create a tile map for our game. Once we've created a tile map and tile set file, we'll load those files into our game using the GoTiled library, which is available on GitHub. To extract individual tile images out of a tile set, we'll call subimage. Subimage isolates part of an image without copying any image data. So if we make any changes to the source image, those changes will be reflected in the subimage, and vice versa. Here we see a 64 by 64 source image and an 8 by 8 subimage. When drawing anything onto the screen using EbiTengen, it's helpful to be aware of the potential optimizations that are available to us. One optimization comes into effect when we make multiple successive draw calls where the source and target image remain unchanged. When we do this, EbiTengen is typically able to batch those calls together, resulting in better performance. So when we implement a rendering system to draw our tile map onto the screen, rather than drawing the tile at the top left of the screen and then the tile next to it and so on, we'll draw all instances of the first tile in the tile set and then draw all instances of the second tile in the tile set and so on. If you haven't yet, download and install the Tiled Map Editor from mapeditor.org. Once you've done that, open Tiled and click File, New Project. Browse to the directory containing your game, and enter a name for the project. Click Save, then click File, New Tile Set. Enter a name, and then browse for the tile set image. You can find the tile set image and other relevant files in the code repository of this tutorial. In tile width, we want to have 8 pixels, and tile height, 8 pixels. Leave margin and spacing as 0 pixels. Click Save. Save it in Asset, Tileset, and we'll save it as tileset.tsx. Now that we have a tile set, we can create a tile map by clicking File, New Map. leave the drop-down options as their default value, and change the map size to 32 tiles wide by 18 tiles high. We want to also change the tile size to be 8 pixels wide by 8 pixels high. Click OK. And here's our new map. We can now click on one of the tiles in the tile set shown in the sidebar on the right, and if you don't see that tile set, use the sidebar on the left to open your tile set and then go back to the map we were just looking at. So now that we have the tile set in our sidebar, we can click on one of the tiles and then click on the map to paint. Once we're finished painting, click File, Save All. Save the tile map in Asset, Map as map.tmx. Now that we have our tile set and tile map ready, we can take a look at the code responsible for loading and drawing them onto the screen. We'll skip over the code that's duplicated from previous tutorials. First off, we import the GoTiled package, and we define a few constants, specifically the tile, tileset, map, and screen size. We also define a loadMap function, which takes a map name, and using that name, we build a file path, and we pass the contents of the file at that file path to the GoTiled library. And what we get back is a struct representing all of the data in that tile map file, making it very easy to work with. In our game struct, we now define a tile set, tile map, and a slice of Ebiton images, which represents each individual tile in the tile set. We now define a loadTileSet method, and the first thing to note is that this is called after we load the tile map. So we first load a tile map, then call loadTileSet, and here we are referencing that tile map we just loaded as the M field of our game. So the first thing we do in loadTileSet is ensure that the number of tile sets referenced in that tile map that we loaded is equal to 1. If it is, we store a direct reference to that tile set. And again, this is a struct that represents all of that data. Once we've done that, we load the source image belonging to the tile set. Once we've loaded the tile set image, we then populate the tile images slice with sub-image references for each individual tile. We do this by calling getTileRect on the tile set we loaded. We provide this method with a tile ID, and it returns a rectangle isolating that tile in the tile set. So using that rectangle, we can call image_sub_image and isolate just that tile in the tile set. And once we've created that subimage, we store it in the tile images slice. In Initialize, we load our map and load the tile set. In Draw, we create a Draw Image Options, which we reuse multiple times, and we loop over each of the tiles in our tile set by tile ID. This outer loop will determine which tile is currently being drawn. Within that loop, we loop over each of the tiles in our tile map, and we compare each of those tiles with the tile that we are currently drawing. If the tile in our tile map and the tile we are drawing don't match, we'll skip over that tile. We'll also skip over that tile if it's marked as nil or empty. When it is one of the tiles we want to draw, we calculate its tile position within the tile map, and based on that, we calculate its screen position, and that allows us to call drawImage and provide the relevant tile image to draw the tile onto the screen. Let's see the result. In the next tutorial, we'll learn how to handle tile map collisions using EBI Tenjin. See you there.